Hello everybody, welcome. I am Mark McLean, Sparky Mark. How are you guys doing on this fine Saturday? Let me know in the chat where in the world you are located. Where on this fine planet are you guys located? Now I'm in London, in England, and it is about 5 in the afternoon here. I can see Ollie, you're in Mosquito, Wisconsin. Fantastic, in the United States. How about the rest of you guys? If you type into the chat, then I can see where you guys are from, and obviously it won't show the message to other people, but let me know where you're at. Where on this fine planet are you? Now, as I say, you are completely, well, this is completely live, so you can see me live. Now, I don't know with your parents as well, but if you want the name changed on the Zoom account, so if you're watching live, Ebne, I can see from the USA, and Raza as well from the USA, fantastic. But if you'd like your names changed because you're using a parent's account or your friend's account or something like that, please let us know in the chat. Just say change my name to, please. Fantastic. And Araya, is that the way? So we should change your name from Kajal to Araya, and you're in New Jersey. Fantastic. Now, are you watching with your parents or friends, or let us know who's watching as well, because it's super useful. And then that way, as I say, when we're building this, that we can try and make sure it's fun for them as well. I have, you've just written Raza, is Raza, R-A-Z-A. It's just your name in Zoom there. Perfect. You're with your mum. So hello to parents too. Right, great. So as I said, we are fully live right now. Now there's a couple of important individuals that I would like to introduce you to in just a second. We'll do that in a second. But we are going to be doing the Spring Force set today. Now I know some of you guys really enjoy these, which is fantastic. You enjoy doing them with me, which is great. So if you're going to be doing them with, that's fantastic. I know also some of you guys just enjoy watching. I'll be doing a full unboxing, and I have another camera so we can actually see what's going on. And we'll be talking also about the science that's going on behind this. So we'll be talking about forces, we're going to be talking about friction, we're going to be talking about some cool stuff today. Now, right, I can see the vast majority of you guys from the USA, but also some people from the UK and elsewhere too. Fantastic. Great. Now, I said two important individuals. Now, the first is Rez, that's R-E-Z. Now, Rez is in the chat, so if you have any questions, if there's any problems with your audio or video, please let him know in the chat, and he can try and sort this out. And we're going to be doing the Spring Force today. All right, fantastic. We're doing this Spring Force today. Fantastic, good question there. Perfect. Now, Rez has written hi everybody in the chat under MEL Academy there, and that's R-E-Z. So say hi to Rez. Now, that's one important individual. The other important individual is this chap here. This is, hey buddy, how you doing? This is Owlie. Hey, what's occurring, Owlie? Everything okay? Fantastic. Are you excited about today's session? Yes. Owlie's very excited about this session because we're going to be making a super fast car that is going to be powered, not an electric car, not a wind car, but it's going to be powered by a spring alone, which is actually pretty cool, actually. So we're going to be talking about spring forces and elastic energy as well today, which is pretty cool. And yes, you really enjoy this one, don't you? That's fantastic. All right, thanks, buddy. Now, for any of you who have, I can see a few familiar names here. If you haven't met Owlie already, Owlie, no, Owlie, don't worry, definitely wasn't gonna say you're my stuffed toy, because Owlie doesn't like being called a toy. He thinks he's a real owl. Yeah, and sometimes I forget. Yeah. Okay, so yes, Owlie, you are definitely a real owl. No, okay, look, I know my voice sounds like I'm being sarcastic and I don't really mean you're a real owl, but no, you're definitely a real owl that lives in a house with a human being doing science experiments. Yeah. So anyway, I used Owlie on some early demonstrations for MEL Science, and now if I did any of these sessions without him, I think you guys would be pretty annoyed. So here he is. It's okay, the real star of the show, Owlie. Anyway, this is Owlie, and yeah, you can help me with the building. Fantastic. All right, brilliant. I'll see you in a bit, buddy. Thanks. All right, perfect. So Today we're going to be building the spring force set, but we're also going to be talking about forces and friction and elastic energy as well, which is pretty cool. So one of the cool things about these weekend sessions that we're doing that are completely live is, well, I guess one of the things about them is that they're live and anything could happen. So hopefully everything will go okay. But also one of the benefits of them are that you can ask questions. So now I can see that Alex says, you've watched the Spring Force before, but you didn't have the kit. Do you have the kit now? Will you be able to build it with me? Fantastic. And please let me know in the chat. Now, you can see Owly and me, but we can't see you guys. So I kind of rely on your messages and your comments and your feedback, and we'll be doing some little polls as well, just to kind of, just make sure you're still alive and you're still awake and you're there. But essentially, yes, if you do have any questions, I love receiving your questions. Now, obviously, if you could try and keep them related to forces and motion, that's great. But to be honest with you, kind of love all the science questions, so please feel free to send your questions through. Okay, perfect. So what we're going to do is get going with the spring force. So we're going to just do a bit of an unboxing for you now, so you can see what is going on. So this here is the set here. This is the spring force set, and what I'm going to do is I'm just going to push it out of this cardboard covering here. So this is the box that it comes in. I'm just going to pop this down here. Don't worry, Owly, I promise I will clear up. Promise. I know he's very good at making me clear up after the sets. Anyway, so let's have a look at this. You're going to come and have a look too. Okay, buddy. All right, perfect. So now within the box, what we have is fantastic. So Alex, you'll be building it today. Brilliant. So anyone who is going to be building it today, if we can get everything out of the box that we're going to need. Okay. So the first thing is we'll need the instructions. Okay, which are here. Now, Owly often calls them the destructions. Hopefully, we're not going to be destructing things, but there we go. So that's the spring force instructions. We also have these two chassis here for the actual cars that we're going to build. We've also got these two finishing posts, but we'll deal with those in a bit. So we just pop those over to one side. And then also within the set, you will get various components. Now, what I would love for you guys to do is to just open this out. I'm going to pop you here, Owly. There we go, is if you open them out and place all the pieces in front of you so you can see them. Now, within the instructions here, right on the first page, there's a list of components here. So you've got all the different components that are there, and then and we're going to just double check that everything is there for you, okay? And also just open up this. Here we go. We've got all of these pieces here. So I'm just going to lay these out in front of me so it's easier to do this. Now, obviously, you've got these two little bags, which I won't open just yet. We've also got these large wheels and small wheels here too, and these axles here. Okay, there we go. So, right, I'm just going to lay all of these out in front so I can see what's going on. Now, in fact, what I might do is lay them to one side so they're easy to locate, and then also so you can see them there at home. Now, let me know in the, as I said, let me know in the chat if you're going to be building this too. Or if, I know that some of you guys have built them already, but you like kind of watching the kind of show now and then learning, as I say, going a little bit deeper into the science of what we're, what's actually going on here. Okay, fantastic, good. So let me know. Right, so I have all the pieces here. And what I'm going to do now, also within the set, is this little hexagon. I'm going to talk about that in just a bit. But essentially, there is an app called MEL Kids. Okay, so what I'm going to do is just ask you guys. There's an app called MEL Kids. It's completely free. In fact, the MEL app, there's a MEL Chemistry and a MEL Physics and a MEL VR. There's also MEL Kids, and I'm just wondering. And Raza, I see you're building it. Fantastic. I'll obviously let you guys get all the pieces out. Rez, I wonder if you could post the link to the to MEL Kids app, please. And this is for smartphones and tablets alike, both Android and also Apple as well. And they are completely free. And I do recommend getting it. And that is what this is for. Okay, so we'll talk a little bit about that a little bit later. Fantastic. Okay, all right. Now Barry has fantastic. You said your car has gone to goes to one side, not straightforward. Okay, we'll have a look at those. Now Rez has just posted a link in the chat. So if you do have the MEL Kids app, already, great. But if you don't have it, that's okay. It is completely free, and I do recommend. And now Ollie's asked, we like the app, but it doesn't have this project listed. Now I have to say, I had exactly the same thing. I couldn't see it, so I then updated the app, and just as I hoped, right at the bottom, there is the Spring Force one as well, which is pretty cool. But I'll be showing you that now. So even if you don't have the app, or you can't get it because you're watching this right now on a tablet or something, please don't worry. You don't have to get it now. It's just my recommendation, because as I say, they're completely free. And Owlie and I love playing with these apps. The guys who developed them are really, really cool. I have to say the guys at MEL Science have really done a great job with those. So as I said, completely free. Might as well. But I'll be showing you anyway how that works. Right. Spring Force, let's get building. Okay, so we've got the list of components, and what I advise doing is it's a good idea to check through your list of components and just make sure that everything is there. Then obviously there's the standard comic section where they are looking at geysers, and then we get to the first part here, which is the actual blueprints for building the car. So that's why they're blue. And so let's have a go. Now, kind of a bit like Lego, there'll be step-by-step instructions, and we're just going to follow them bit by bit. If there's any problem, please let me know in the chat, and happy to see it. And Rez and I, between us, will hopefully be able to kind of help you to work through those. But obviously, it can be useful sometimes to have the help of a responsible adult, just sometimes if just putting bits together. Don't worry, we'll have a look at those in a bit. All right, fantastic. Now, what I'm going to do is grab 2 axles. Okay, so let me quickly go here. The axles are these ones here. Okay, and what we're going to do is onto the axles, we're going to place these little plastic cups. Now, I'll show you the... now, what these actually do is they reduce something called friction. Okay, now friction, when 2 objects rub together, so say for example I rub my hands together, they actually start to get warm. Okay, now that is due to friction. Friction is a force that opposes motion. Okay, so if anything's in motion, it works against it. So by putting these on there, it actually allows our wheels to turn with less friction. So I've just placed one of those on there. Okay, and so this is the axle, and there we go. Okay, now as I said, if you need to know the name of any piece as well, okay, these are actually called grommets. Okay, these are called grommets, but essentially you place the grommets onto the axle like this. Okay, now hopefully that should be nice and clear for you guys. And here we go. And we're going to do both axles, and we're going to use all 4 grommets here. Okay, there we go. So those are the axles, and all 4 grommets have gone onto there. Now, we're actually going to start putting the axles onto the main sidebars that make up the body of the car. Okay, so these sidebars look like this. Now, please let me know, how are you guys getting on? Have you been able to put your grommets onto your onto the axles there? Okay, so let me know how you're getting on. Obviously, don't want to rush too much, and you know, but also want to keep things moving. But before we do that, I'm just going to talk about forces. Okay, so there's a gentleman called Sir Isaac Newton. Okay. In some ways, but an incredible brain. Now, one of the big work that he did, a lot of different things he actually worked on, but forces is essentially the one that he's probably most famous for. Now, in terms of forces, what are forces? Well, in fact, Ali, can I borrow you for a second? Thanks, buddy. Okay, so let's have a look at this. Now, forces come as pushes or pulls. Okay, so if this is Ali, I'll just move these here. Okay, if I gently push on Owlie in this direction, you don't mind if I do that, Owlie? Yep, okay, fantastic. If I just push on Owlie, look, he moves. okay? And the same thing, if I pull on Owly, I'll do it gently, Owly, I pull him along, he also moves. So forces are pushes or pulls, okay? Now there are forces that are contact forces. That means where they're touching. So in this case, I was actually touching Owly as I pushed him, and the same thing when I pulled him. But there are also forces that are non-contact forces. For example, magnetism, where they don't necessarily need to touch, but you know, with magnets, they end up sort of pulling towards each other or repelling. So now you don't need to worry too much about contact, non-contact, but I'm just kind of going broadly over what forces are, okay? But mostly, just understand, they are essentially a push or a pull. And in fact, what we're building here, we're actually going to be building a little car that is powered essentially by a spring. And the spring is what's going to give it the push to keep going. Now, I have to say, it'd be a pretty boring car if it didn't go anywhere. So the forces that are provided by the spring are pretty cool for us in what we are building here. Okay, fantastic. So Raz asked if I'll go a little bit slower. That's fine. Hopefully you're okay on this next bit. Right, so let's have a look at this. Now, I've got my... I've got the two sidebars here, okay, but I'm only going to need one to start with. Now what I'm going to do is on the sidebar there are these large circles at either end, large holes at either end, and we insert the grommet insert the white little grommet there into the hole at the end of the sidebar, and then I take the other axle and I insert that into the hole at the other end of this side beam here, okay, like this. Now hopefully you can see that nice and clear. Okay, fantastic, good. And that is step 2. Now step 3 is we take the other side beam, okay, the other sidebar, and we place it in the same direction. So you can see that there's an arrow end here and an end without the arrow, and we're just going to make sure that we place it here. We place the grommet into the hole, so the axles will go through. Now hopefully that's nice and clear for you. Can you see that you've got the end here with the arrows? Now this will be the front of the car and this will be the back, okay, of our racing car here. All right, fantastic. Now we need a way to hold these together, okay? So there is a piece and it'll be called the brace. Now the brace looks just like this, okay? It's got a little hole in the center. Now there is a piece that looks not too dissimilar to it, but the brace is the one that has the little hole in the center here and these two little arms. Now what that does is it goes to towards the front of the car, so which is where these arrow parts are, and you place it where these two little notches are. Okay, so this is the brace. Remember, it's got the one with the little hole. We're going to place that over there. Let me just place this. Now, obviously, for anyone who's just watching, don't worry, I'm just making sure you can see exactly what's involved in this, the process of seeing what's going on here. And there we go. Hopefully it should be nice and clear for you. And right, and for anyone else who is building with me, hopefully I'm not going too fast for you. So hopefully you guys are going okay. Right, so now, while I'm waiting for a couple of people to catch up, what we're going to do is grab the chair part. Okay, this is the back of the chair. Okay, this is for our little driver who is going to drive it, and it's called the car backrest. And then we also have the car seat here. Okay, so this is the backrest and this is the car seat, and all you have to do is take the car seat and insert that, this little place here, into this hole at the bottom. Now you can see there's a little notch at the top. There we go. I'm just going to insert that into there, and that will clip in place, and that is the car seat. Now whilst you guys are catching up on doing that, okay, I'll make sure I've got this here so you can see. This is the back seat here, and this is the seat, the backrest and the seat, and you just slot that in. I'm just doing a little poll for you guys. What is a force? Okay, so let's have a look at this. So what is a force? Okay, sorry, Rez didn't give much notice there, but hopefully we should have the polls for you guys. But have a think, even if, what do you think a force is, okay? Does no one really know? Or is it mysterious black stuff? Or is it a push or a pull? What do you guys think? What is a force? Now, I know I just did this, so I'm not trying to condescend you. I'm not trying to be like, oh, what's 1 + 1? I get it, but just trying to get the good, fantastic, really, really good, great answers straight away, and just share the results for that. 100% of you guys, all of you guys, which answered very quickly, well done, got it absolutely right. Forces are a push or a pull, okay? Fantastic, well done. All right, now, okay, now one of the forces that we need to overcome is a force called friction, okay? Now, as I said, I was rubbing my hands together. Friction is, as my hands move across each other, there is a force that actually tries to slow my hands down. And as I work against that, it actually generates heat. Now it turns the movement energy into heat energy, and that is friction, okay? The same thing happens if you are, say, driving a car, or someone's flying a plane, or any object that needs to move very quickly needs to move through the air. Now, the air around us is made of tiny, tiny particles. In fact, they're made of atoms, okay? Now, atoms are all around us, okay? I'm made of atoms, you're made of atoms, even Owlie's made of atoms, okay? Owlie's made of atoms too. Yes, you are made of atoms, I'm made of atoms. That's a good point. Yeah, Owlie thinks that I'm made of more atoms than him because I'm bigger than him. Yeah, that's a fair. It's not quite as simple as that, because sometimes also the atoms can be a bit more spread out, but that's pretty good, Owlie. Nice work. Okay, so the world around us is made of atoms. Now, one of the ways that we can see that, very often we can't actually see them, but we can see their effects. One way we can demonstrate the effects is if you wave your hand at your face. So say, for example, we take our instruction manual here, the instructions, and we wave them, there we go. You can sort of see that my hair is moving. What can you feel hitting your face? Okay, so if I wave my hand at my face, try not to hit your face, there we go. What can I feel hitting my face there? Okay, so if you wave your hand at your face, you can type into the chat, let me know. Even if you don't want to type it, that's okay. Maybe say it out loud to someone nearby you, whether it's a parent or something. What can you feel if you wave your hand at your face? What can you feel on your face? Okay, Ebony's got an answer, Raza's got an answer, Ollie's got an answer, fantastic. Great, now Ebony says the wind, fantastic, I totally agree with that. Raza says the air, I totally agree with that. Araya says the wind as well, windy, yeah. Ollie says air, fantastic. Wind, air, says Alex, fantastic. Great work, guys. Perfect. Da air. Nice, says Ebony. Yeah, exactly right. In fact, we can actually feel atoms hitting our face. So the air around us is made of these tiny little things called atoms. And in fact, this big thing behind me here is called the periodic table. And it's a list of the 100 or so naturally occurring atoms. Now, I know that each one's got their own little symbol here, like that Zn is zinc, and we've got a B for boron and that kind of thing. But these are different types of atoms. Now, essentially here, these atoms floating around, we can't see them because they're so tiny that we can't see them, but we can feel their effects. And in fact, if I just look out the window just over there, I can see the trees moving, and that's because they're being hit by atoms. But of course, we know this as wind or air. So you can actually feel the air moving, but actually hitting lots of little atoms hitting my face there. Right, now, the thing is, when a car moves or a rocket moves or even a submarine going through water, any object that needs to go through air or a liquid has to get through it. I don't know if you've ever been swimming. You have to kind of get through it's best to be streamlined. We're trying to get through the atoms with minimal friction. Friction, as we start to speed up, will slow us down. Okay, and it always, by the way, works in opposite directions to the motion. So, okay, if Owlie's going, you want to go that way? If Owlie's going this way, okay, that's Owlie's motion, okay? So Owlie's motion is this way. You okay, buddy? Yeah, there we go, fantastic. There he goes. The friction will work in the opposite direction to try and slow him down. Yeah. And try and slow him down. So that is why, by the way, sports cars and rockets and things are very streamlined, so they can sort of cut through the air. Okay, move the atoms. Perfect. Now, one of the questions that Ebony said is, can we use a microscope? Now, atoms are so tiny that we can't even see them under a microscope, but they fit together kind of like building blocks to make larger objects. So, for example, Owlie here is made of atoms. I'm made of atoms. You're made of atoms too. We're all made of atoms. but they're so tiny that we can't see them. So why is it that Owly, yes, that's you, why is it that we can see Owly even though he's made of atoms that are so small that they're basically invisible? So remember, these atoms are so tiny we can't even see them, especially not in the air and things. But why is it we can see Owly? Wait a sec. Owly, I can see you. Guys, can you see Owly? He's not just my imaginary friend. You can actually see him, right? This is awkward. Oh, okay, you can see him. Okay, so fantastic. Good. Now I can see the response. You guys can. Okay, you can see him. So why is it that we can see him? Good. Now, let's have a look. So Ebony says, because we can't see cells, we can see us. Okay, it's good. I have a microscope my mum brought for my birthday, says Alex. Fantastic. Brilliant. Any other answers? Yes. Well done. So I can see some answers about how people... Okay, people, or owls, we're made of atoms, but there's so many of them fitting together. There's so many of them fitting together that we can see Owly. Kind of like, as I said, like building blocks. So you might not be able to see a single brick, say for example, in the distance, but if lots and lots of bricks make a very big building, so we can kind of see those too. Now, Alex, wonderful. Have you been using your, Araya says big, yeah, fantastic. Alex, have you been using your microscope for anything cool? Do send us pictures. We love seeing them, don't we, Ali? We do. And if you want to email us, you can email us at melacademy@melscience.com. So, and ask Rez if he can pop that into the chat for you guys. All right, fantastic. Let's keep building. Okay, so we've been talking about forces. Now, I'm just going to quickly ask you friction. Okay, you put blood on it. Fantastic, Alex. Fantastic. All right, good. So let me ask this little poll. Number 2, in what direction does friction work? Okay, so if we have friction, what direction does it work? Does it all directions? Does it oppose motion? I go against the motion, side to side or up and down? Which way does friction work? Okay. What does it do? In what direction does friction work? Now, do you remember I had Owly going this direction? What direction did the friction work? Did it go in the same direction as him, or was it in the opposite? Did it oppose the motion, or was it in the same? What do we think, guys? Okay, I think pretty much everyone has voted. Fantastic. Now, we have a bit of a 50-50 split here, which is fantastic. Well done, guys. So let me just share the results with you. So we can see all directions and it opposes motion. So let's have a look. What is the correct answer? Now, now this is a bit of a difficult one. So we've kind of left it a little bit open, which is okay. So remember, I don't need you to get the right answers here. So please don't worry. It's more just to make sure we're keeping the dialogue going. And by the way, I couldn't see who pressed what. But it is true that friction can go in all directions, but the specific one I'm talking about here is it will always go in the opposite direction to the motion. So if Owly is moving this way, the friction will always go in that direction. If Owly, you're okay with it, Owly's going this way, the friction will always oppose. So it is true. So if you clicked all directions, that's fine, because it could go in all different directions, but essentially it will always go in the opposite direction to the motion of if you're moving. So if I'm driving this way, I will get the wind on my face essentially as I'm moving through. Okay, fantastic, good. Now, Rez has put into the details there for MEL Academy. If you have any pictures of these, if you're building this and you want pictures, or you have any drawings of owls, Owly just said if you have any drawings of owls, you're welcome to send those too. He loves those, so that's fantastic. Right, let's get going. Okay, so let me go back to the tabletop. We've got this here. Now, hopefully, I think everyone is caught up. What we've got here, I can see, yeah, you have. This is the chair, and the chair slots into these little slightly slanted slots here. Okay. And it just slots in there. So let me show you again. Okay. We've got these slightly slanted ones here, and the chair, the bottom of the chair, slots in there. Okay, so the chair's facing slightly up, so nice comfortable ride. There we go. All right, fantastic. Good. Okay, so that's step 5 done. Now the step 6 is we're going to take the wheels. So these are the wheels here, and we just need to pop them onto the front axles. And the front obviously is where these arrows are here. Now what you can do is you might need to rotate these axles around to make it a little bit easier, but we just slot the wheel onto there. Okay, there we go, fantastic. And then the same thing on the other side as well. We just make sure the wheel, we rotate the axle just to make sure that that fits on there too. Okay, and so if we roll this backwards forward, that is these are the front wheels, okay, of our little car. All right, of our racing car. Now we need to do the back wheels, and we have these rather large wheels here, and they slot on in just the same way. Okay, so just make sure that focuses. There we go. And they slot on in just the same way. One on here and one on there. Okay, and they should move backwards and forwards like that. Okay, now if any of you are having problems with it, so I see a couple of people in terms of it moving side to side, make sure all of these parts are tight. Okay, now you always get a little bit of side. Now good. Now so Alex, which part are you saying is hard? So let us know in the chat. Brilliant. Fantastic. Let us know in the chat. And okay, so I'm going to pause just here. So the steps that I've just done essentially were putting the car seat in. So remember, you slot it into this slightly diagonal, slightly slanted slot. And then we take the front wheels, okay? We take the front wheels and they have this little slot here. Now, if, for example, you can't get it on at all, so say, for example, you can't get it on at all, try rotating the axle, okay, by a quarter turn, and then it should slot on much more easily, okay? So if there's a problem there with getting them on, you can just rotate it, and it should go on much more easy, and just push it on there so it fits on nice and tightly, okay? Yeah, putting on the tiny wheels. Yes, so did that help? Rotate, you did those, fantastic, you did it, Raza. Alex, let me know, did the tiny wheels, did they go on? Again, let me show you one more time. What we do is this. So you take the wheel like this, and you can see that it's a little bit rectangular. It's not a square. So if it doesn't go on in one direction, try rotating it round a little bit to see if you can get it to fit on more easily. And then what can also sometimes help, if you just move it side to side, it can go on a little bit more easily there. So maybe I can let Rez have a chat to you in the chat and just see if there's anything that we can do to help. So as I say, just one more time, you take the wheel and it should slot in there and you can push it right on. Okay, all right, fantastic. Good. So let's have a look at this. Now we're going to have a look at step 8. So I'm going to just take the car and I'm just going to move it over here for a second. And what we've got inside this little bag here, I'm just going to empty these pieces out. What I'm looking for, okay, is this little piece here. Okay. Now, if you look at the components list, it's known as the spring holder. It actually kind of looks like a pair of compasses. There we go. Little drawing circles. There we go. There's the spring holder, and we're going to also need the spring as well. Okay, now this one's a little bit fiddly, so I'm going to just take a little bit of time just to show you how this works. Okay, so this is the spring holder. Now what we want to do, okay, is this. We want to turn the spring, okay, we want to turn the spring so that we can place one of the arms of the spring through here and up there. Okay, so what we're going to do, as I say, let me just, now if it's upside down, it won't go in properly. You'll just, essentially it won't quite go in properly. The spring won't fit in. But what you do is you turn it upside down so that this arm here is on the bottom. So this one's low, this one's on the bottom, this one's on the top. Okay, so the arm that you're going to stick through is on the bottom here. I'm just making sure it's in focus there. And what you then do is you slot it through the little circle, okay? And what you can then do is if you just wiggle it around a little bit, the spring will actually go into that hole there. And then what we do is we take this arm, we make sure it is in between the two. So this arm of the spring is in between these two arms of the spring holder here. Okay, so as I say, what's going to happen around the back here is you've got one sticking out like this. Okay, fantastic. Now, if you're having any problems with the tiny wheels, Alex, is there an adult or someone who could maybe try and help you with it? Okay, and Raz is asking if I can do this one again. Yes, very happy to. So let me just quickly. I have to get it out. It's a little bit harder. So here we go. Let me make sure I do this. Right. So what I'm going to do, in one hand, I'm going to pinch between my thumb and finger. I'm going to hold onto the spring holder here. Okay. Okay. The other hand, between my thumb and finger, I'm going to hold the spring. Now, this is very important. I'm actually holding here the top one, and it's quite hard to sort of see. So let me bring it closer. So hopefully that will focus nice and clearly. I'm sorry, guys, as I say, just trying to make sure. I'm holding on to the top one here, and this one here is on the bottom. Okay, so between my thumb and finger, I'm holding the top part of the spring, and between my thumb and finger here, I'm going to be holding the spring holder. Then what I do is I take the, let me make sure that's in focus for you. So I take the bottom part of the spring, and I just slot it into that little hole there. Okay, so here we go, into that little hole, and then what will happen is if I push down with this part, this thumb here, okay, the spring, and also then push, I'm going to push the spring in, and it should pop in there. Okay, then what I want to do is with this little piece of the spring here, I want to make sure that it is in between the two parts of the two bits of wood. Okay, so it's in there. Fantastic. All right, cool. Now, as I said, please get if you need a little bit of parental help. I think this is probably the most complicated part of it. So please make sure you do ask a responsible adult just to help you with this bit. But as I said, it just takes a little bit of fiddling. And by the way, also just a little tip, okay? So if you're finding it hard to get the spring into there, what you can actually do, now please be very gentle with this because you obviously want to break the wood here, but you can actually pull the arms apart a little bit and push the spring in. So just pull these arms a little bit apart. Don't not too much, because Ali and I had that problem before. There you go, just pull the arms a little bit apart and you should be able to push the spring in there. Okay, all right, fantastic, good. So let's keep going and let's have a go. Now, so what we're going to do is we now need the long column here. Okay, so it'll be listed, it'll be launched as the launch stick. Now the launch stick actually goes in between the arms of the wooden spring holder. And now have a look at this. Can you see that my top part of my spring is also in there as well? So I've got the top part of my spring here, and I just fit the launch holder in there. Okay, in between that. Now, once I've got my launch holder there, there is a piece that looks like this. Okay, now, in fact, there are two pieces that look quite similar, so be a little bit quite careful of this. What we've got is one with rounded edges, one with flat edges, and we're going to want the rounded one. Okay, now it's actually known as the convex washer. Okay, so it's the convex washer, which looks like this. And what we then do is we take the convex washer and we slot it over the launch stick here, over the top. So we bring it, let me from underneath so you can see. We take this and we slide it up. Here we go. There we go. And what should happen, if you just give it a little bit of a push, it should clip on over the top here. Okay, fantastic. Good. Then what we want to do is take the other washer, okay, which is not the convex one. Here we go. Let me just quickly. Now, if you look on the list, it'll be known as the flat washer. And we, again, so you do the convex one first, which just has these kind of curly edges. And then we take the flat washer and we slide that up and it should just clip in place there. Okay, Fantastic. All right, great. Now that, as I say, is probably the most complicated part of it. So once you've got this, everything should be a little bit easier. Now what we're going to do is we take the front of the car, and this is step 10. Now, at the end of the whole launch mechanism, okay, you will have the spring sticking out here. So I'm going to just show you, this is where the spring, let me make sure you can see it, little hooked spring there. Okay, what we need to do is we need to slot that little spring onto or into the little hole here right at the front in between the two of those. So, and then what you do is once you've got that in, there we go, it should stay in place. So let me show you that one more time. Here's the front of the car. You take the little hook of the spring and we slot it through the hole. There we go. And it should come out the other side just here. Okay, fantastic. Good. All right, so that's that. That's our launch mechanism. Okay, and this is what's actually going to give us the thrust and get things moving. Okay, right. So now, just before we do that, I'll let everyone catch up. Let us know in the chat how you guys are getting on. If you need a little bit of parental help, that's okay. Just you know, have a look. And it's the step that is quite important is the step 8 in the thing. And if you need some help, obviously getting the spring in, you can actually just move the little arms of the wood spring holder apart a little bit. But please do obviously be careful. Fantastic. Did it? It's still really shaky. Fantastic. Good, well done. Ebony is asking, is this lesson about making cars? Well, sort of. Now, we are obviously making this particular car, which is great, and it's going to move and things like that. But actually, it's about understanding some of the science that's going on behind this. Now, we're going to talk about something called energy right now. Now, energy is all around us, okay? We sort of know energy from heat. Things that heat up, we have a lot of energy. For example, the sun. Our closest star has a large amount of energy and it keeps the Earth warm, but it also gives off a large amount of light as well. Okay, so light energy, heat energy. There is also movement energy, sometimes called kinetic energy. Now, don't worry too much about the you know, remembering all the different names, but just remember there are different types of energy. Now, there was a fixed amount of energy. Okay, so scientists believe there was a fixed amount of energy at the beginning of the universe. Okay, and the Big Bang, which is where we think that the beginning of the universe, where we actually time as well as space began. But essentially, right at that moment, there was a fixed amount of energy, and slowly, it's been spreading out, but not so slow, been spreading out, spreading out. Now, energy collects together, and one of those essentially can be transferred from one form to another. Now, obviously, I don't want to go too far into it, but I just want to kind of give you an understanding that energy is all around us. It can be in the lights that I have here that allow me to see. There's electrical energy as well that allows your computer to work. There's a number of different types of energies. And the core rule of energies is energy cannot be created or destroyed. There's a fixed amount of energy. It can only be transferred from one form to another. So, for example, if I want to use my calculator here, what I've got is electrical energy. In fact, there's chemical energy inside the batteries. The batteries transfer to electrical energy, which then eventually give off light, and that's what allows me to see it. Same thing with a smartphone. Now, my computer is using electrical energy to create sound and light, and there's lots of different transfers going on. Now, the one we are most interested in, fact, there are two we're very, very interested to, is something called elastic potential energy. Okay, do we got energy? Yes. Do we have energy? Yeah, absolutely. Absolutely. We do have energy. And we, in fact, now this is actually something that is absolutely crazy, is the atoms around us. Do you remember all the atoms we talked about? The atoms in the air, the atoms that make up Owly here, all of the energy, all of these atoms are actually made of energy. Say what? Say what? But That's for another time. Yeah, I know, we can talk about that later. I think Ali definitely wants to. But essentially the key here is just to understand that the universe around us, okay, contains a huge amount of energy. And this energy can be transferred from one form to another. And we can make these transfers very useful. So, for example, what we can do is, if we take there's a spring here. If we pull this back, okay, there is now elastic potential energy. And if I let it go, whoa, it pushes forward. But how can we make that useful? And so this is what we're going to do in this session now. Well done. There's heat or electric. Fantastic, Nate. Really, really good. Now, the key here is we're going to try and make this energy useful. Okay, so that's where we're going to carry on within this set. Here we go. Now, give me 1 second. Cool. All right, let's have a look here. So there we go, the tabletop here. So what we're going to do is let's get this going. So we've built this. I've done step 10, which is there together. Now what we're going to do is we need to, again, make this useful, as I said. So what we do at the front of the car, let me make sure you can see this. If we take one of these small columns here, okay, what we're going to do is, you see at the front of the car, you see there were these little arrow things here. These are the arrowheads here. Okay, so these are here. What I'm going to do is I'm going to stick this through here. Okay, I'm going to stick this through here. But what we want to do is, before it comes out the other side, we actually want it to go through the center of the spring. So this takes a little bit of just, you know, maneuvering. What I'm going to do is stick this through here. Okay, and we're going to stick it through the center of the spring. Okay, let me bring this a little bit closer. So this is where the spring is here. Okay, and we're going to stick this through here, through the center of the spring. And then we just need to adjust it so that it comes out. Here we go. The other side here. Okay. There we go. So that might take a little bit of maneuvering. Okay, let me just do that again so you can kind of see. So I've got my spring here, and I want to set it so that I can put my spring through here, through the center of the spring, and then through the other side here. There we go. There we go. Now you might need to twist it a little bit to be able to get it to move. And once we've got this through here, there are these, here we go. Now there are these black foam crosses here. And what we're going to do is we're going to place them either side, just here. Okay, so here we go. And place these either side just here, and what they'll do is they'll hold those in place, hold the that in place. Okay. Now Raz is asking, can we do questions? Yes, of course, absolutely. Now let me just quickly ask you, we talked about, now let me give you a little clue here. We're just going to do a poll in just a second, okay, but essentially the key here is, if we, for example, a washing machine, okay, which I've just had a new one, it's stored in my house and it cleans my clothes, it's fantastic, okay, little washer dryer. Now that is going to use what kind of energy, and what is it going to turn it into? Now I'm just going to go over a few core types of energy. There is electrical energy. Do you think of maybe washing machines there? There is also sound energy. There's light energy. There is heat energy, okay, or thermal energy. But there is also something called kinetic energy. Now that's a very fancy word for movement energy. All right. So just a little poll for there. How is energy transferred in a washing machine? Okay. So take a second, because it could be is it electrical? So I think we're pretty happy that it's probably going to be electrical, not to give you, but which one of these it is. Is it electrical to kinetic energy? Or is it electrical to kinetic and thermal and sound and light? Or is it electrical to elastic, just like these ones? Or is it chemical soap powder to sound and heat? What do you guys think? Okay, so this is a bit of a weird one. Right, this is definitely a bit of a weird one, but it's more just to kind of get you thinking here. So what does a washing machine need? We obviously have to plug it in, don't we? So what kind of energy do you think comes from a plug? But again, you don't need to get the right answer. This is a very, very tough question. This is just more just to see, and also you don't have to do it. two, either. Remember, I don't see the who answers what, but it's just getting an idea of what you guys are thinking. This is pretty tough. Do you think it's electrical to kinetic, which should be electrical to movement, or do you think it's electrical to movement and heat and sound and light, or do you think it's electric to elastic potential, which is what's going on in a spring here, or do you think it's chemical energy of the soap powder to sound and heat? So what do you think? What do you guys think? Okay, I can see almost all of you guys have voted. Let's have a look. Okay, fantastic. So I can see it's a bit of a 50-50 split. Now, I can see quite a few of you. Now, let me just quickly say that the soap powder, okay, doesn't necessarily provide the actual energy for this to go. So that was a good guess. That's a good one. But as I said, you don't have to get them right. Let me have a go here. The electrical energy is transferred to kinetic energy. Okay, it's to the movement energy. So washing machines will spin it round. But the other thing is, washing machines don't just spin. They will also create heat. They warm up as they do, so that heat up the water. They will also create sound. You can hear the washing machine when my one's going. I can hear it. And also there's little lights on there as well. So the correct answer actually is electrical energy from the electricity to the kinetic and the thermal and the light, sound and the light. Now, I know that was a pretty tough one, so I didn't need, as I say, didn't need you to get it right. That was just a throwing it out there. But please, as I say, let's keep going. Right, so I went to the 2-1. Perfect. Yes. Well, I tell you what. So as I say, don't worry. I don't get to see who answered what, but well done. Thank you very much. And the most important thing is, I love the fact that you guys engage in these sessions, and because as I say, I can't see you. You can see Ali and I, but so thank you so much for answering all the questions. You guys are awesome. Okay, right. Let's keep going. So we've now got the last little bit here. So what we're going to do is this. We've now got the here we go. Right, let me grab the next part. So my next part here is called the eyelet. And the eyelet is this little shape here. And what we need to do with the eyelet, again, this is a little bit fiddly, but it's okay. So what we're going to do is we take the elastic band and we put the small little black elastic, and we place that over the pointy part of the eyelet. But can you see I'm doing that with my thumb and finger? Now what I'm going to do is this. I'm actually going to push with my thumb and finger over the top of the eyelet here. Okay, now that popped off. I didn't do it for long enough, but as I say, it's a little bit fiddly, but we push it over there and you can see it actually goes over the top here. So let me do that one more time for you. So we have the little eyelet, we take the elastic, there we go, so I'm just making sure it's focused for you, and then what we do is we just feed that over the top there so that it's around, oh, there we go, sorry about the focus, there we go, there we go. There we go, so it's around the top of the eyelet. Then what we need to do is we need to tie the string to it. So I'm just going to unravel the string, and if you do it nice and slow, it shouldn't get tangled. I nearly did. So what we then do is we take the piece of string and we feed it round the back of this little hole here, and I'm going to pull about a finger's worth, okay? But it can be your finger too, don't worry. So just maybe a little bit longer if you have very small fingers, so a little bit longer. So it's, there we go, just at about a finger's worth or so. Okay, maybe 1.5 inches, 2 inches maximum. And then what we do is this, we're going to tie a knot in it. And the way we tie a knot is this. So we have the long part of the string here, okay? And I'm going to take the short end and we bring it round the back and we feed it. So as I say, sorry, here we go. We take it round the back and we feed it into the hole at the front, okay? So as I say, what we do, we take it round the back and feed it through the hole at the front here. And then I can pull that. You can pull that with both hands and it makes a tighter knot. Then what I'm going to do is I'm going to do the same thing again. So I just bring it round the back. There we go, great. So I take that round the back here and I'm going to feed it through the hole here and pull it tight. Now in fact what I'm actually going to do is I'm going to do that a third time. You don't necessarily have to do it a third time. The two should be fine, but if you want to make it really, really tight, there we go. and get some help from an adult if you need to on the tying, but that should be there nice and clear. Then what we need to do, okay, at the other end of the string is we're going to tie another knot. So I take the string. So this is the long part, and I have a short part here. So what I'm going to do is I'm going to take the short part and put it behind the long one, and then you feed it through there. You should create a little knot there. Okay, so that creates a little knot in the string. Now you can always double that knot up if you need to. Okay, so you can always make it a little bit bigger if you need to, just like that. But I would say that one single knot should be absolutely fine. Right, cool. Now what we're going to do is we need to put the chassis on our car. We're actually going to cover the car in something pretty cool. So let's have a look at this. What do you guys think? Which one would you like? Shall I do the blue or the yellow? What do you think? What do you think, the blue or the yellow? Okay, I can see quite a few people. Blue, fantastic. So what I'm going to do is put the blue over the top here. Okay, so we just take the blue and we place it over the top. So what you might need to do is just bend. So you turn this over and just bend, fold it over, and then press like this, and fold over, press like this. Okay, and we're going to get the rivets out of the set here. Okay, these are the little black rivets, and what we do is we place the car, oh yes, and this is the control panel here for the car, so we fold this down, and what we're going to do is place this over the top here. Now what you've got is these little holes here and here, and what you can then do is with this rivet is just at the front here, there we go, we just push this through the hole here, and I'm going to use my thumb, there we go, to push that. The same thing happens at the back here too. There we go. My thumb, push it round there. I'm going to just rotate this round, and I will put those rivets on there. Okay. Now, obviously, while you're doing that, what I'm going to do next is I'm going to attach, once I've done this, I'm going to attach this little eyelet here. Okay, we place this onto the end of the launch rod. Okay, so let me just show you how I'm going to do this. Place that onto the end of the launch rod here. Okay, and it's about a finger's width from the end here. Okay, so just at the end. Okay, and it should hold just in place because of the elastic. Let me make sure that's in focus. Perfect. All right, now what I'm going to do is we pull this back. Okay, so let me show you the way to do this. What we're going to do is we take the string. Okay, now on this back wheel, so this is the last stage, everyone, for you guys to do this. Okay, it just takes a little bit of time and practice to do this, and then you can race your cars to your heart's content. Just here on the back axle, okay, just on the back axle, you can see there's a little notch just there. And what you do is you rotate that notch there, and you take the string, okay, with the knot in it, and you place the knot just over, okay, just over the notch. So you've got the string in there with the knot. Now what you can then do is you can hold this a little bit tighter, and what we do is we just gently roll the wheels round. Okay, and what you'll find is that it should trap. Now it takes a little bit of time to get used to that, to just trap that in there, but once you've got it, well done, fantastic for everyone who said blue. I've definitely chosen the blue. Here we go. Now what we do is we keep rotating this, and what that's going to do is it's going to pull on this string here. Okay, it's going to pull on this string here, and as I rotate it, what's going to happen is this launch rod starts being pulled back and pulled back and pulled back. Okay, but let me make sure it hasn't, there we go. So what I'm going to do here is just push this here. I'm going to just try and keep this in the center. Okay, so there we go. Perfect. Now we've got a minute or so to go, and I'm going to pop this in. Now what we then do is we roll this round and down here, and eventually what will happen is that the launch rod will get low enough so it can fit into that little notch at the back of the seat. Okay, and then what can happen, we can let go of it. Now that is our car. Now what we've done is we've loaded the spring at the front with a lot of elastic potential energy. And I'm going to move everything out of the way here. Okay, Ali, you want to come and watch this? Okay, fantastic. Right, here we go. Let me move all this stuff out of the way. And what we're going to do is with the car, okay, I'm going to take this and I'm going to move this over to the side here. So this little slot, and let's have a look at the car. Oh gosh, let's see. I think I've got quite a slippery, surface to do it on. So I'm just going to place this here, which is a little less slippery. Here we go. Right, let's go. Whoa, there it goes. Wow, fantastic. Now, did your car move? Have you been able to get it to move? I know it's quite a lot of instructions there to do just at the end. But as I say, if you can get it to charge up, just slot it in and then get it to move. Now, one of the things that happens is my table's quite slippery here. So what you can do is you can add elastic bands around the wheels, or you can add band-aids or plasters, anything, or even a little bit of plasticine or some kind of clay to actually, or blue tack just round the wheel to make sure it doesn't slop. And try it on wood, try it on lots of different surfaces. I have to say, this car is pretty cool actually. I think Ali and I we love these cars. And you can obviously then make your own chassis as well. Now let us know how you think about this session. What do you think about this session, Ali? What, best session ever? Oh, because you love this car. You're a bit biased though, I have to say, Ali. I think Ali loves this car. Now, what else have we covered today? We've been talking about forces, haven't we? We've also been talking about energy and atoms as well, which is pretty cool. Yeah, you're made of atoms, that's true. And essentially, with this, what we've been doing here is, in order to make this car go, instead of using electrical energy or chemical energy, which is what a car would use in the gas or the petrol, essentially, petroleum, what would actually happen is we've been using an elastic potential by using this spring here. Now, have you been able to build your car, guys? How did you get on? I hope you did. If you did, there's also part of the set here which you can make your finishing posts as well. So I do recommend having a go at those and send some pictures. Now I can see a couple of people still doing it, but that's okay, guys. Now hopefully you'll understand a little bit more about the science behind this, and obviously you can re-watch this session as well if there's any problems and things. There is Rez can send you the link there. And I can see Araya, yours went super fast. I'm amazed. Now I apologize if we've gone a couple of minutes over. I just had a little problem with the focusing things, but you have been super patient, and thank you so much for all your wonderful questions and your lovely comments. Now, where does the map go, the sticker for this lesson go? Where on the map? Well, have a look. I haven't got it just to hand, sadly, but it should go very nicely onto the map. But I guess any problem, let us know, and we're happy to answer those. All right, we better get going, hadn't we, Ali? I know we've gone a bit over. Thank you so much for your patience, and lovely to see you. And we'll see you again very soon for another MEL Science session. We love building these sets. Yeah, we do. Okay, take care, guys. Oh, there we go. Fantastic. And we'll see you again very soon. Take care. Goodbye.